This is section 7.4, and we're continuing on with learning about the sine and cosine graphs. So remember, the standard form for a trig graph is y equals, there could be a number a in front. Remember, we could use either sine or cosine. So let's say we'll use sine today. So sine, and then b, parentheses, x plus or minus a number c, and then plus or minus a d. Okay, and so remember, let's see, in section 7.1, we learned about just the basic sine and cosine graph, none of the letters there. And then in 7.2, we talked about how the letter A talks about the amplitude, right? A vertical stretch, if you stretch it out vertically. We talked about in 7.3 how the letter D gives us a vertical shift, whether it moves the whole thing up or down. And so today we are going to talk about what does the letter B right here in front of the parentheses do. Okay, so today's about the letter B. Kind of sounds like Sesame Street, doesn't it?
Clap, 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 clap. What's the letter? 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 The letter of the day is B. It's the letter of the day. It's the letter of the day. It's the letter.
Okay, sorry about that. I just had to do it. Okay, so the letter B is going to determine the period. And hopefully you're thinking to yourself, well, I thought we already knew that the period of both sine and cosine is 2 pi. Well, remember, if you're looking at the basic sine function, like say y equals sine of x, or the basic cosine function, yeah, the period is 2 pi. But where is the b number on this particular equation? Well, isn't the b the number that's right in front of the x? So what number is right here? And let's see, right in here in front of the x. Well, if you don't see a number there, isn't it assumed to be 1? So what we're saying is if the b is 1, then yes, the period is 2 pi. So what if that number in front of x is not 1? In other words, what if there is a number there, like 2 or 3 or 5? Well, in that case, then the period is going to change. Okay, so the formula that we use is, we say the period always equals 2 pi over b. So it should make sense. If b is 1, then that's why the period of this was 2 pi over 1, or just 2 pi. Okay, so look at example 1. First thing we'll notice here is that the b is this 2, right? Because that's the number in front of the x. It doesn't matter if there's parentheses or not. The b is always the number right in front of the x. So the period would be 2 pi over b, which is 2. So the period is actually pi. So that means one full section of the sine graph has to happen in only pi units. Not 2 pi units, but only pi units. So what that means is, if you think about the basic sine function that goes all the way out to 2 pi, remember, starts, ends, and halfway, up to 1, down to -1. So here is the basic sine function that goes all the way out to 2 pi. So if I were to take that graph and squeeze it up and get the entire shape over here into that distance of only pi units, then that's how we're changing the period. So essentially we would say that the period represents a horizontal. Now I'm going to use the word stretch, but a lot of times it's not a stretch, but it's like a squish. You're squishing it up into a smaller amount of space. It's possible, depending on what b is, that you're stretching it out. You know, maybe you stretch it all the way out to 3 pi or 4 pi. So I want to show you, instead of, because you're not going to have a snipping tool where you can just kind of squeeze it up like I just did. So let me show you how you would approach the graph when you're asked to graph by hand, okay? So when I look at this, the first thing I would suggest is mark off whatever the pi is. Since I know whatever the period is. Since I know the period is only pi, so that's where pi would be, right? Because every unit or every little tick mark represents a half a pi. That's going to always be our standard. That's not going to change throughout this entire unit. So what I would do is I just kind of mark it off. I just say, okay, between 0 and pi right here, I have to fit in one full section of the sine graph. Well, remember how I gave you those handy dandy hints? I'm just going to write them here. Remember how we said on sine, first thing we said was start, end, and halfway at 0? Well, that's still true. You start, you end, it's just that now my ending is at pi and halfway at 0. So these little standards that we wrote down doesn't change. That's why I tried to get you in the habit of saying these phrases over and over again to yourself. And remember, the other thing we said about sine is we said, okay, halfway between those, you're up to 1 and then down to -1. So that means halfway between the first 2 points, you go up to 1. And then halfway between the last 2 points, you're down to -1. So do you see we've got the same basic shape? It's just squeezed up into a distance of only pi units. Okay, I'm not going to write these out every time. I just wanted to kind of show you that the same phrases still work. Okay, so look at the second one. Since my B number is 4, the period is going to be 2 pi over 4. Or the period is pi over 2. So that means I've got to squeeze up one full section of cosine in a distance right here of pi over 2. Okay, well, remember the phrases for cosine. We said you start and end at 1. Halfway, you're down at -1. And then halfway between each of those is where you're at 0. So here's one section of cosine that happened in a small section right there of pi over 2. Okay, so look at example 3. So in this case, I have an A number, but I also have a B number. Okay, so let's start with the period. Well, we know that the period is going to be 2 pi over B, but remember B is 1/2. I personally think the easiest way to simplify this, because this would be no calculator, is you may remember way back when I said anytime you have a fraction over a fraction, and we do have a fraction over a fraction, right? This is like 2 pi over 1 over 1/2. I think the easy way to simplify is to do outer, so the outermost would be 4 pi over the innermost would be 1. So my period is 4 pi. Okay, so let's mark that off. Remember, every line represents pi over 2. So there's 1 pi, 2 pi, 3 pi, and this would be 4 pi. So I'm going to mark off all the way out here to 4 pi. So in that space from 0 to 4 pi, I'm going to fit one full section of sine. And in this case, where sine, it normally starts, ends, and halfway at 0. So start, end, halfway at 0. And then remember how we said the sine function goes up to 1, but if the amplitude is 3, if the A is 3, then that means instead of going up to 1, we're going to go up to 3. And notice that happened halfway between the first 2 zeros, and then halfway between the second 2 zeros, I'm going to be down at -3. So this represents a sine function with a period of 4 pi, but an amplitude of 3. Okay, so let's try another one. So I've got both an A and a B, right? So in this case, we're going to say the period is 2 pi over 3. And I know that doesn't simplify, but that's fine. We'll just estimate. So remember, this is going to be pi. So 2/3 of pi, wouldn't that be somewhere between a half pi and 1 pi? And you don't have to be exact, but it's going to be somewhere between here. So I'll just say 2/3 is going to be something like this. So notice I'm just marking it off. I'll call this 2/3 because it's a little more than half. So that means I have to fit one full section of of the cosine in that space? Well, for cosine, remember we said you start and end at 1, but again, in this case, since the amplitude is 2, I'm going to start and end, because remember, I have to end wherever I've marked off my period, start and end at 2. Halfway, so where is halfway? I don't know, I'm just guesstimating what would be halfway between those 2 points. I'm down at -2. I'm just guesstimating, that's halfway between. And then halfway between each of those, I'm at 0. So I've got this skinny little cosine graph that's squeezed up in there in a distance of 2/3 pi. Okay, so far all I've been doing is amplitude and period. So let's put it all together, all right, everything we've learned. Now, I've listed the A, B, and D out here to the side just to kind of help you think through what they all do. And I'm not looking for you to write down just what those numbers are. Like, I don't need you to tell me that the A is 3 and the B is 2 and the D is 1. I mean, I need you to know that, but I don't need you to write that down in a blank. What I need you to know is that if A is 3, that means the amplitude is 3. And if the B is 2, that means the period is 2 pi over 2. So the period is pi. And if the D is 1, that means the vertical shift is 1 unit up. And this is what I want you to write in these blanks, okay? For letter B, don't just tell me pi, tell me the period is pi. For letter A, don't just tell me 3, tell me the amplitude is 3, and so on. Okay, so my suggestion is, remember how when we first did amplitude and vertical shift, I had you do it in 2 different graphs? I think anytime you have a vertical shift in there, you need to do it in 2 different graphs. So my suggestion is, let's do these 2 pieces together in the first graph, and then I will bring in this last piece for my final graph. Okay, so let's just start with the first 2 pieces. So mark off your period. I'm going to put a little star here. I always do that part first. So I have a period at pi, so mark this off at pi. Remember, every little line, every little tick mark represents a half pi. So there's pi. And then this is cosine. So let's think about it. Cosine starts and ends at 1, but in this case, since the amplitude is 3, I'm going to start and end at 3, and then halfway I'm at -3, and then halfway between each of those is when I'm at 0. So this would be the graph that includes the amplitude of 3 and the period of 2 pi. If I were labeling it, I would say this is the graph of 3 cosine 2x. It does not include the +1. Okay, now I'm going to bring in the vertical shift. So I'm going to take every single one of those 5 points and move it up 1. Let me move this name just so it's not, I'll put it down here, okay, just so it's not in my way. So I'm going to move every single point up 1. So this one goes up 1, the end goes up 1. Remember, I like to move them up in the same order that I plot the points. I'm not saying you have to. I'm never going to know how you do it. I just think it's helpful. This one's going to come up 1, and then each of these will come up 1. So my final graph that has the amplitude and the period and the vertical shift is this pink one. So this would be the graph of 3 cosine 2x, and it does include the +1. Now, what I will let you do, if you don't want to have to label every time, I will let you use like colored pencils or something, you know, or 2 different colors, as long as I can see some kind of color code. Like, see over here how I put the pink around that vertical shift, and I put the blue around the first 2. So you can do something like that to tell me which one is your final graph. Okay? Understanding the pink one is the final graph, right? Because that includes all 3. All right, so let's look at example 6. So remember what I said. Yes, the A is -2, and the B is 3, and the D is -1. So for amplitude, we don't say that the amplitude is -2. We just say that the amplitude is 2. Now, what does that negative do for me? Remember, that negative is going to cause me to flip it. So just in general, as far as notation, we say that the amplitude is 2 because that just gives me an idea of how high and how low it goes. Okay. So the period is going to be, so period is 2 pi over, the B number is 3, so 2 pi over 3. And then when I'm ready for it, I know that the D means that the vertical shift is 1 unit down. Okay, so I'm going to do this part first. So I'm going to mark off my period of 2/3 pi. Remember, this is pi, so 2/3 is going to be somewhere in here, right? Somewhere between 1/2 pi and 1 pi. This is the sine function. Remember, the sine starts, ends, and halfway at 0. And then normally halfway between that, I'm up at 1. But in this case, since my amplitude is 2 and it's flipped, halfway between there, I'm down at -2. Halfway between those last two, I'm up at +2. So this is the graph of the sine function that brings in both the amplitude of 2 flipped over and the period that's been adjusted. And now I'll bring in the final graph that moves everything down 1. So all of those zeros are now down here. This minimum point moves down 1, and this maximum point moves down 1. So here is my final graph that represents all 3 pieces. Okay, so you'll notice then that the homework is going to bring in all 3. So I want you to do the same thing where you do the first graph that brings in the amplitude and period, and then the second graph will bring in the vertical shift.